Hello guys, welcome. In this tutorial, I will explore the concepts behind list compression and how to implement list compression and nested list compression in Python. List compressions provide a concise way to create lists. Common applications are to make new lists where each element is the result of some operations applied to each member of another sequence or iterable, or to create a subsequence of those elements that satisfy a certain condition. For example, assume we want to create a list of squares. So the first thing that comes in mind would be using for loop. Okay, based on the range of numbers from 0 to 10, we can make a new list which contains the square of the number of each number in a list and append to the newly created list, which is squares. That this creates or overrides a variable named I that still exists after the loop completes. We can calculate the list of squares without any side effects. However, Python has an easier way to solve this issue using list comprehension. List comprehension is an elegant way to define and create lists based on the existing lists. So this is equivalent to the following list compression. Yeah, so we get the same result. And instead of using for loop, this compression is an elegant and easier way. And list compression is also considerably faster than processing a list using the for loop, which is more concise and readable. A list compression consists of brackets containing an expression followed by a for clause, then 0 or more for if clauses inside that bracket. So the result will be a new list resulting from the evaluating the expression that is look like this. For example, we can use a nested for loop and up with the conditional statements in the nested loop that compare the two elements in the lists are not equal and then creates a new list if they are not equal. But instead of using this, we can use list compression that can perform the same result. Yeah, so this is what list compression, the fastest way to do such kind of problems. So if statements in the list compression can utilize to modify existing list or other tuples. For example, if let's assume we have list of rows, and without list compression, we will have to write a for statement with a conditional test to create a new list if the item or the fruit contains n character. Yeah, banana, orange, mango, and ananas contains n character, and just obtaining if the fruit contains n character, and this is equivalent to this one. Yeah. So the second one, or this compression, is better than using the for loop because this is the fastest way. All right. Next, I'll explore what is nested list compression. So the initial expression in a list compression can be any arbitrary expression, including another list compression. For example, let's consider the matrix. All right, this is 3 by 4 matrix. And to transpose this matrix as this is row by columns, and we transpose the columns to rows and the rows to columns. So we can use a for loop to transpose the rows by columns. Let's try this. Range of 4 because we have 4 columns, because each of the rows has 4 columns, and we iterate in the range of 4. Now we can iterate through the row and append each row in the post new list. All right, this is one way. And turn is the same as, for example, transpose for every I in the range of 4 and transpose row. We also transpose the rows using for loop. This is what using the nested for loop. But this is equivalent with the list compression, which is the most efficient way. Look, the nested for loop, the inner loop is converted to the nested here in the list, and the outer loop is also the outer loop in the list compression, the outer list compression. So this one is the nested for loop, which is the nested list, and this is the outer loop and the for loop, and this is what's called the outer list compression. So we can use nested list compression. Okay, this is called nested list compression. But in the real world scenario, you should prepare built-in functions to complex flow-state methods. So the zip function can do a great job for this use case. For example, list zip, we can use unpacking. That's the create. We got the same result with the previous one. We can also apply the built-in in the squares here. You see? So this is a built-in function that can perform any tasks efficiently, especially in the real-world scenario. You could use such built-in functions to perform list compressions. So we can also use list compression in dictionaries and sets as well. I hope you enjoyed this tutorial. Don't forget to like, share, and subscribe. Write comments below. Thanks for watching.